only in a small area, basically. So let me just explain this through the following example. If you have a function which says something like this, yeah. Let me say this, for example, is -3. This is -4. This point is -6. Here, 5. This is 3, 4, and so on. Yeah, -2, 2, like this. Suppose you have a function, this function here. Its graph is like that. This function has how many local maximums? So it has 2 local maximums. Huh? One of it is here. That's a local maximum. This is also a local maximum. Yeah. How many local minimums does it have? 1. Yeah. This is a local minimum of this function. Now, the absolute. What is the absolute maximum of this function? The absolute maximum of this function is the number 4, is the value 4. That's actually the biggest value of this function on the interval. Absolute maximum is always on a certain interval. On the interval from -3 to 5, yeah? We are looking at this function on the interval from -3 to 5. Its absolute maximum is 4. What is its absolute minimum? It's -6. Very good. Okay, great. So you can see the difference between local and absolute. Absolute usually just one value, one single value, which is the largest possible value in that interval. Absolute minimum, also one single value, which is the smallest value of the function on the interval. Now, that's how you see it graphically. Yeah? Graphically, you can see where is the local maximum, local minimum, absolute maximum, absolute minimum. But suppose you don't have the graph, but you just have a function like this. Suppose I give you this function and I want to study it on the interval from -3 to 2. What is find the absolute maximum? Yes, and find the absolute minimum. Now, to do that, well, you would have done this in Calculus 1. First, what you need is to find the critical values of the function in the interval -3, 2. So first, you need to solve the derivative equal. So pay attention, please, because we will, for functions of 2 variables, we will follow more or less the same method. So first, we need the critical values by solving the derivative equal to 0. So that means 2x plus 2 equal to 0. That means x equal -1. So x equal -1. So this is the critical value. And this number is in the interval, so we're okay. After that, after you find the critical value, you can do this. Take x and take your function f. What is the domain of the function? We study it from -3 to 2. Yeah? and then you put the critical values inside, -1. And then you find the value of the function at these 3 points. So you put the end of the interval, -3, 2, and you put the critical values inside. So at -3, you need to find the value of f. So substitute in the function, not the derivative. Please be careful. So substitute in the function f. You will see by putting -3, 0, exactly, 0. And then substitute -1 in the function f. You get -4, huh? -4. Okay, some of you already did this. And then at 2, substitute, you will get 5. Now, look at these 3 values. Now, these 3 values, which one is the largest? 5. So 5 will be the absolute maximum of f on the interval -3, 2. Its biggest value will be 5. What is its absolute minimum? -4, that's it. Absolute minimum of the function f on the interval -3, 2. So, do you understand a little bit what's happening here with functions of one variable? This, by the way, I'm just doing what you did in Calculus 1. This is something that was part of Calculus 1. So you find, if you want to find the absolute maximum, absolute minimum, first find the critical values of the function in the interval, and then you can make a small table like this. Put the end of the intervals here, -3 to 2. Find the values of f, and then compare all these values. The biggest is the absolute maximum, and the smallest is the absolute minimum. Okay, so did you understand this? Did you understand what we just did? Okay? All right, great. Now then I can move to functions of 2 variables, and we see what happens there. Okay, so here, 1 variable, 2 variables. Let's see. Okay, 2 variables. Find the absolute extrema. I warn you, this is a little bit a long process. I hope you will not find it too difficult. But if you focus, it will be fine. So find the absolute extrema of this function. It's a function of 2 variables. What is its largest value? What is its smallest value? On the region are bounded by the lines y equal 2. So the line y equal 2 is the horizontal line here. Y equal x, which is the blue line. And y equal -x, which is this line here. So in the end, we're getting a region R, which is between all these 3 lines. And in that region R, the function f is defined. So it has a value at each point. And of all these values, there will be the largest one. So what is it exactly? What is the largest value of the function and what is the smallest value. Okay, so this is how we're going to do it. So we are going to look first inside the region. Then we will look at the function on the line y equal to. So first we do the inside, then we will do the line y equal 2, find the maximum, minimum, etc. on that line. Then we will do the line y equal minus x. And finally, we will do the line y equal x, like this. And then we find several numbers and we take the biggest will be the absolute maximum and the smallest will be the absolute minimum. So let's get going. So number one, inside the region. Inside R, I want to find the critical points. Yeah, I need now to, it's a bit like, you may remember the interval, we just, the function of one variable. So you need to have a look at fx, which is 4 minus 4x. So we make this equal to 0. And we find fy, 3 minus 2y, and we make it equal to 0. So here, very easy to solve. So we get x equal 1, and we get y equal, what is y? 3 over 2, so? Okay, great. So we have a critical point, which is 1 and 3 over 2. So this is a critical point. And then after that, I can find the value of f at this point. Okay, so substitute this point, by the way, I can check it's inside, it's 1, 3 over 2 is inside the region R. So it's okay. So this point belongs to the region R. It's okay. So we can find its value, substitute in the function f. Can someone try and do it and see? So x is 1 and y is 3 over 2. If you substitute in the function f, what are you getting? 37 over 4. Yes, thank you. 9.25. Okay, great. Thank you, girls. Thank you. So 9.25. This value, we keep it there on the side. We will need it. We will need that. Now, what's the second step then? We're going to study our function where number 2, on the line y equal 2. Yeah, number 2, on the line y equal 2. Because I want to find the maximum in that region R, including the boundaries. So I need to look what's happening on the boundary of the region R. So inside, and also I want on the line y equal 2. So now, because y equal 2 is equal to 2, we substitute in the function. So every y here, you put 2. Yes? So it will be 5 plus 4x minus 2x squared. Remember, y is equal to 2 on this line. So this will give us when y is 2, 6, and this will give us 4, yeah? So it's going to be plus 6 minus 4, plus 6 minus 4. So I get basically the function minus 2x squared plus 4x plus 7. Yes, plus 7. Yeah. Okay, good. Let's call this function h of x, yeah, because it's only a function of x now. It's only a function of x, so it's a function of one variable. I can find its maximum, its absolute maximum, the way we did the example before. Okay, now first, on the line y equal 2, you can see it here. X goes from where to where? From minus 2, yeah, minus 2 to 2, exactly. So now I have a function of one variable which I will study on the interval minus 2 to 2. Now this is what we did before, so I need its derivative. So it's minus 4x plus 4, make that equal to 0, so you get x equal 1. So now we have to have a look at the three values. H, it's like that table, but I'm not going to make a table here. I will just now look at the three values and I put them here. Yeah. So I now substitute x with minus 2. Can you check what we're getting here? This is basically f at minus 2, 2. So it's this function where you put x equal minus 2. What do you get? Minus 9. Good. Minus 9. Excellent. Then we have f of 2, 2. This is 7, yeah, if you substitute. And finally, this is f of 1, 2, which will also be 9 like this. Okay, so we have another three values to add to this value here. So on the line y equal 2, here are the possible maximums or minimums. Minus 9, 7, or 9. Okay? Now I will do the same thing on the line y equal minus x. Number 3, what happens to our function on the line y equal minus x? So this time it's f of x, the y is minus x. Exactly. So I substitute, I go to the function f here. Every y, I replace the y with what? This y will be replaced with minus x. Exactly. So I will replace it with minus x and simplify. And this time I will give you the answer. It's minus 3x squared, yeah, plus x plus 5. This is what we will get on the line y equal minus x. But now look at the line y equal minus x, this line. X will go from where to where on this line? From minus 2 to 0. Yes, exactly. Thank you. So I'm going to study this function on minus 2, 0. So this function You can call it g perhaps. Yeah, we can call it g of x. So yeah, its derivative is what is it here? Minus 6x plus 1 equal to 0. So we get x equal 1 over 6. So now I have three other values to add where the function f may have an absolute maximum or minimum. So x is 1 over 6. Let me just make it clear here. X is 1 over 6. And of course, if x is 1 over 6, then y will be minus 1 over 6. Yeah? Because y is equal to minus x. So therefore, now I have another 3 points, so which are f of 1 over 6 minus 1 over 6. Oh, wait a minute. Wait a minute. Minus. So, no. X equal, yes. There is a problem here. X equal 1 over 6. Yeah. Is not in this interval. So, yeah, it's not in the interval minus 2, 0. So there is no point, this point not there. Because on the line y equal minus x is only from minus 2 to 0. And when I solve this, I'm getting 1 over 6, which is not in this interval. Yeah, so I will write this. So this point does not belong to the interval minus 2, 0. So ignore it. So there is no need to find a y. There is no point for that. So therefore, here I only need now basically g f at minus 2, 2, which is minus 9 at the end of the interval. This and also at 0, 0. So f at 0, 0, which is going to give us 5 like this. Okay. Now, finally, I want to complete this by looking at the line. On the line now, what is left of the boundary? 1, 2, 3, 4. So we are left with the line y equal x. And on this line, so the function f will be fxx. And we substitute, we get minus 3x squared plus 7x plus 5. And the interval, what is the interval x? If you look at the boundary, number 4 here, x goes from 0 to 2. Yes, thank you. Thank you, girl. So on the interval from 0 to 2. So again, this function, you can call it whatever you want to call, maybe k, yeah, of x now is just a function of one variable. Yeah, so its derivative is minus 6x plus 7, and we put that equal to 0. So x is 7 over 6. And because we're on the line y equal x, so y is also 7 over 6. So now we have basically, we will have the values of 7 over 6, 7 over 6. If we substitute in the function, I think we get something like 9.1. Yeah. Okay. And we also have the points at the end of each. So we have this point 0, 0, and the point 2, 2, like this. But I think we already have these values. F of 2, 2 is 7, and at 0, 0, we already have it. It's 5, so we have another 3 values like this. So you can see now all these values of f, which we have on the right side. What is the largest one? If you look at all these values on the right side, what is the largest value you can see there? Not exactly, it's the largest is this one, yeah? 9.25, yes. So that would be the absolute maximum. That would be the absolute maximum of the function in the region. And what is the smallest? If you look carefully, minus 9. That's it. So the conclusion that we are getting from all of this, the conclusion is that f has an absolute maximum of 9.25 at x equal at xy, at the point, let me just I want to put the value but also the point where 9.25 at the point 1 3 over 2. That's where it reaches its absolute maximum. And f has an absolute minimum of minus 9 at the point minus 2, 2. So minus 9 happens at the point minus 2, 2. So that is how we do this. I know not an easy thing, I think. Okay, let me check this. After the derivative here, yes, basically, let me explain this by looking back at that example I gave you of a function of one variable. Let me consider this function here. But this time, instead of considering it from minus 3 to 2, suppose I consider that from 0 to 2. Yeah. Let's say I only want it from 0 to 2. Now, when you try to solve f dash equal to 0, we get x equal minus 1. Now, this minus 1, is it from 0 to 2? Is it in the interval 0 to 2? No. So when you make your table, there is no critical value here. There is no, you will only have, yeah, you will have 0 here and 2 here and nothing in between. Yeah, there is no critical value in the interval 0, 2. Do you understand? So if we are only looking, it's like that. So the interval is very important. The interval you want here, extremely important. It will tell you whether you can consider the critical value. So let me go back to that example. And I will just finish by, yeah. So here, your critical value is 1 over 6. Now look at the interval -2 to 0. 1 over 6. Is it in this interval? No, yeah, it's not there because this is a positive number. -2 to 0 is a negative. They're all negative numbers. So this number is not between -2 and 0. So don't use it here. Don't use it in these values. Do you understand what? So that's basically what happened. So a little bit of a maybe complex thing here, but don't worry too much about this one. I don't think. Okay, so we will stop here today. Thank you very much for your patience, girls. The other points. Okay, the other points is like good point. It's the you see the line y equal -x. Look at the line y equal -x. It goes from this point to this point. Yeah. The line y equal minus. Yeah. What is this point? So it goes from this point, which is -2, 2, to this point, which is 0, 0. So, yeah, the line y equal -x from -2, 2 to 0, 0. So when you look at the line y equal -x, just look at -2, 2 and 0, 0, like this. Do you understand? Same thing, yeah, same thing for, look at the line y equal x. The line y equal x is the blue line. It goes from 0, 0 to the point, this point is 2, 2. Yeah. Like that. So from 0, 0 to 2, 2. The line y equal x, yeah, from 0, 0 to 2, 2, but this time we have a critical number in between them. So you need to consider that also, that value. Does that make sense? Yeah. Yes, we only, yeah, this is what you do always. The intervals, look at the points at the end of the line, yeah, like 2, 2, 0, 0, and add any point which you found from these equations, from the equation, the derivative equal to 0, like this. Sometimes, yeah, sometimes you may not have anything, just the end points. Sometimes you need to have the points. Okay, thank you very much indeed, girls. Thank you. Have a nice day, and you take care. Okay, good work, and I'll see you next time.